Hey guys, we're on Unit 11. This is day 2, and we're going to talk about inscribed angles. In our warm-up, it says state whether the lines represented by the equations are parallel, perpendicular, or neither, and explain your answer. So parallel and perpendicular depend on having either the same slope or negative reciprocal slopes. So what's nice about this equation here is that it's already in y equals form, so I can already tell the slope is 1/2. So we're going to go ahead and rearrange this equation so we can tell what the slope is as well, and then we'll be able to judge them. So distribute, a negative times a negative is a positive, and 1/2 times 2 is 1. Okay, we go ahead and subtract 4, and we end up with y equals negative 1/2 x. 1 minus 4 is negative 3. Okay. And so now we can go ahead and tell our slope here is negative 1/2. And since these slopes are not the same, okay, we have negative 1/2 and positive 1/2. So they're not the same. And they are also not negative reciprocals. They are opposite signs, but they are not flipped. Okay, so they're not perpendicular. So we're going to go with neither, and we're going to go ahead and say not parallel. Slopes are not the same. And we're going to say not perpendicular. Slopes are not negative reciprocals. All right, so our warm-up is finished. All right, so coming down here, we talked about angles. We talked about central angles having their vertex at the center of the circle. Inscribed angles are a little bit different than central angles. They're an angle whose vertex is on the circumference. And whose sides are chords. All right, so you can see an angle inside of our circle here. If we trace out the sides there, the vertex is on the edge or the circumference of the circle. And this line segment here is a chord because its endpoints are on the edges of the circle. And this is also a chord. All right, and that makes an inscribed angle. And inscribed angles are equal to half their arc. So for instance, if this arc is 100 degrees, this inscribed angle would be 50 degrees. Okay, so you can see they're not the same as central angles. Central angles would be equal to the arc. Okay, over here we have an inscribed triangle where it has all 3 endpoints or vertices of the triangle right on the circumference of the circle, and you have 1, 2, 3 inscribed angles in it. Okay, it says that the measure of an inscribed angle in a semicircle. Okay, so you can see here this is an inscribed angle. Okay, and notice that it intercepts. Okay, or has that arc belong to it. And so that arc right there is 180 degrees because it's half the circle. And so this would make that a 90-degree angle since the inscribed angle is half the arc. Okay, and so they're saying that an inscribed angle in a semicircle is always going to be a right angle, a 90-degree angle. Okay, all right, we're going to come down here and do some examples. So in number 1, okay, it says to find the measure of arc AC. So arc AC goes from here to here. Okay, and if we go ahead and we look at the inscribed angles 80 degrees, the arc would have to be 160 degrees, which is 80 times 2. Okay, so that the inscribed angle here is equal to half that number up there, which is its arc. Okay. Number 2, find the value of x in circle O. So we can see this time they're asking for our inscribed angle. Okay, and since this is the arc that belongs to it, which is 70, the inscribed angle would be 35 degrees. Okay, it's, remember, half the arc. And so half of 70 is 35. Okay. Let's go ahead and do number 3. Because given the measure of arc BC being 100 degrees, okay, so this arc here, and the measure of angle B is 70 degrees, which would be here. They want me to find angle A. Well, angle A is an inscribed angle, and that 100 degrees belongs to it. And so half the arc, half of 100, equals 50 degrees for angle A. Okay. Then they want us to find the measure of arc AC. So arc AC is down here. Okay. If we take a look, the 70-degree inscribed angle belongs to it. And so in order for the angle to be half the arc would have to be 140 degrees. So 70 times 2 is 140 degrees. Okay. If we wanted to, we could go ahead and find angle C. We could use our triangle sum. 180, take away 50, take away 70 would leave us 60 degrees left for angle C. And we would have two ways of being able to find this arc if they asked us to. We could go ahead and say, well, the inscribed angle is 60, so the arc would have to be 120. Okay? Or we could have gone ahead and said that 120 is the remaining arc of the full circle. So 360 degrees in the full circle, take away 100 and take away 140. You can see that we could have got the 120 degrees for that arc that way too. Okay. Number 4, it says find the value of Z in circle A. So we can see here that Z is in this expression that we have for this inscribed angle at R. And notice if we follow out the sides of that inscribed angle, this arc, which is half the circle or 180 degrees, belongs to it. And so we can see that this angle here would be half of it, half the arc is 90. And now we can take 4Z minus 10 and put it equal to 90 degrees so that we can solve for Z. Okay? We'll add 10 and we get 100 and divide by 4 and we can find that Z equals 25 degrees. Okay. We'll go ahead and down to this little text box here. It says that the measure of an angle formed by a tangent and a chord is not technically an inscribed angle, but it does follow the same rule for being half the arc. Okay, so in number 5 here, AB is a chord. In circle O, CD is tangent. At B, the measure of arc AB, so this one here, is 100 degrees. And they want us to find these 3 things. Okay. The 2 angles that we see and the 1 arc that's left over. In fact, we can get the arc that's left over if we use 360 degrees and we take away 100. We can go ahead and find that the arc is 260 degrees. So from here, the rest of the way around is 260. Okay. So what they're saying up in this text box here about this angle that's formed, okay, see the vertex is still on the edge of the circle, so it's like an inscribed angle, but only the one side is a chord, the other side is a tangent. But they're saying it follows the same rule. So half the arc, half of 100 would be 50 degrees for this angle in here. Okay, that's angle ABC. And then we have 2 ways to get our other angle. Okay, since this is vertex on the edge of the circle, one side is a tangent, one side is a chord, we can follow that same rule and say, all right, well, half the arc, half of 260 is 130. And this angle can be 130. Or you guys can see that the 130 and the 50 form a linear pair here. Okay. And we could have just gone ahead and subtracted 50 from 180 to get 130 as well. Okay, so either way, this is angle ABD. All right, and this was the measure of arc AEB. All right, and that question's done. All right, I'll see you guys on the back side of notes.